good day, everybody. And yet again, we meet together. And thank you so much for having been patient. I had a little bit of an issue the other day when I was supposed to have a live. But this paper is actually brought to you by Una Lady. So Naledi Lekopa wrote to me and requested that we go through this November 2024 exam. Shout out to you, Naledi. Well, it's all courtesy to you. So I thought that I'll take you through since you're preparing for your final IEB exam. So let's get right into it. I will publish one after the other, one question after the other, just for me to be able to take you through. Now, let's get into the multiple choice section. Right, and see what we have there. Right, so the first one says, which one of the following is the correct formula for tin, right, 4-chlorate? Now, remember, some of you might think that tin is actually a Ti, but it's actually Sn, right? And the fact that it has a 4 there simply is telling us about its oxidation number. So in that case, it means that tin chlorate would be this guy over here. What this number at the bottom tells us is the number of chlorates that there are that are bonded with tin. So in that case, there's 4 of them. And so that's why that is the correct answer. Right, now the next one says, how many moles of iron sulfide are required to produce 32 grams of sulfur dioxide? Now note, in this case, sulfur has an oxidation number from the periodic table of 32, and oxygen is 16 times 2, which is also 32. So we are looking at 64 grams per mole. So we know that number of moles will be mass over molar mass. That will be 32 divided by the molar mass, which is 64, that we just calculated. And so that gives us 0.5 moles, right? But in this case, we were looking for the number of moles of iron sulfide, right? And look at this. For every 8 sulfur dioxide that are produced, there's 4 iron sulfides that are used. So for every 4 iron sulfide, we get 8 sulfur dioxide. Look at this. So in this case, we're looking for how many moles of iron sulfide will give us 0.5 of sulfur dioxide. Now please, I want you to note this is a 1:2 ratio, but what you can do is just cross multiply 8 times x, which will give us 8. x4 multiplied by 0.5, which will give us 2. And so if we divide both sides by 8, then x will be 0.25. So that tells us for every 0.5 of sulfur dioxide, we would have used 0.25, half the amount. And we expected that because for every 4 there's 8, so the correct answer there is 0.25. Right, I hope that you followed that well, and let's go to the next question. So they say to us, beaker A and B contain aqueous solutions of 2 different sodium salts, the concentration and volumes of which are indicated in the diagram. All of the solution in beaker B is poured in beaker A. Right, now, we want to know the new concentration of sodium ions in beaker A is given by. So firstly, remember that we poured beaker B into beaker A, right? So originally in beaker A, we've got 50 cubic centimeters, 0.5 moles per cubic centimeter. So number of moles, concentration times volume. So that will be 0.5, that's concentration. And volume, remember, has to be in cubic decimeters, so that's 50 divided by 1,000, which gives us 0.05. And so when we calculate that, that will give us 0.025. Right, that's the number of moles of, that's for sodium chloride. Now I want you to note sodium chloride only has one sodium for every sodium chloride compound or molecule, right? So which means the number of moles of sodium ions will be equal to the number of sodium chloride molecules that you've got. Okay, for every one there's one. Right, on the other hand, we've got beaker B. Right, again, we're going to say this is concentration times volume. So this will be 0.25, that's the concentration, times the volume, which is 0.03, 30 divided by 1,000, and that will give us 0.03. And so when we calculate that, that will give us 0.000075 moles. But remember, those are the moles of sodium sulfate, okay? But what do you notice? For every one sodium sulfate molecule, right, there are two sodium ions. So in that case, it means that sodium, the number of sodium ions that are here, will be multiplied by 2 times the number of moles of sodium sulfate. So in that case, that means that sodium ions will simply be 2 times 0.0075, and so that gives us 0.015. Okay, so what did we do? We took these, we poured them into beaker A. So the total number of sodium ions will be 0.025 plus the 0.015, okay? But what did we do? Remember that volumes are additive, so we added the 30 to the 50, so that gives us 80 cubic centimeters, and we divide that by 1,000. So our final answer there will be 0.025 plus 0.015 divided by 0.080. Okay, so that is how we are going to get that. Please don't forget the fact that we had 2 of those sodium ions there. So this shows us that we will have twice the number of sodium ions as there is sodium sulfate. Right, let's go on to the next one. They say, which one of the following gas samples will have the largest volume at STP? So let's check. So we've got 48 grams of oxygen. So number of moles in that case will be mass, that's 48, divided by molar mass. Now remember, oxygen is 16, but remember oxygen is O2. So that's going to be divided by 16 times 2. Okay, so that will be 48 divided by 32. That gives us 1.5 moles, right? And then what about B? That will be number of moles 6 divided by hydrogen. Hydrogen is H2, so that's 2 times 1. So that will be 3 moles. And in this case, for C, so this will be B, that will be C, so that will be 16 grams of helium. And remember, helium has got a molar mass of 2. So that's 16 divided by 2, and that will give us 8 moles. So far, it has the highest number of moles. Okay, and finally, you've got at D, you've got 28 grams of nitrogen. And remember, nitrogen is 14, but you've got 14 times 2. So that will be 14 multiplied by 2. And so that will give you only 1 mole. And so the correct answer will be C, because that has the highest number of moles with the same conditions, that is at STP. Right, and so we go to the next one. They say, consider the energy profile graph for a reversible reaction shown below. Right, so the energy profile in this case, you can definitely tell this is an exothermic reaction. We start with a higher amount of energy, we end with a lower energy, rather the products have got lower energy, so that means that we've lost energy in the process. Now they say, which statement or statements is or are true or are correct. So the first statement says P represents the activation energy for the forward reaction. Well, that's not true. The activation energy would have been P minus Q. What P represents is what we call the activated complex. Okay, so that's a point in that case, so that is not true. So statement 1 is untrue. So delta H for the forward reaction is equal to R minus Q. So let's see that. So that's the energy of the product. So remember, delta H is energy of the products minus the energy of the reactants. So the products, that's R, and the reactants is Q. So that definitely would be R minus Q. And we expect delta H to be negative. So statement 2 is correct. So they say a catalyst lowers both Q and R equally and therefore does not affect delta H. Well, that is not true. What a catalyst does is that it will lower the activation energy. So you'll have a lower peak there, right? Q and R would still remain as they are. So that is not true. So in that case, they say, well, only 2 is correct, and that is option C. All right, and so they say in the next one, we've got sodium. I don't know what that is called. We could always try to, let's see. So if we've got CH3, we've got C, that's probably CO2. Okay. I'm not sure what that is in terms of what it's called, but they say it's a soluble salt. That's 1 mole per cubic decimeters of that salt. The species that will be present in the greatest concentration will be. Now remember, whenever a salt ionizes, right, it will break down in that case into, so in that case you'll have CH3CO2 minus, right? Now, remember, when we talk about ionization of salts, what salts tend to do is they will undergo, in this case, a reaction with water, but it's always the stronger conjugate, okay, that will react with water. And so in this case, I know that this will be a stronger conjugate because it comes from the salt, from the weak acid in that case. So you'll have more sodium ions that are still left. Okay, they will not react with water. So as a result, it means that the answer there should be A. Okay, right. And so for the next one, they say galvanic cell is set up using the following half reactions and a suitable salt bridge. They say when the cell operates under standard conditions, the pH, right? So firstly, let's note. So I always use that A and C method, right? I always say, well, you take the one with the smaller potential, and it's going to be 0.4, that's 0.77. And I say, well, which party is in government? That's the ANC. And what does the ANC do? It gives away houses. Okay, so look at this. So if you look at 0.4, that's where the hydroxide ions are, right? It is the anode, so which means we're going to write it in reverse. So which means that 4OH minus would therefore become 2H2O plus O2 and giving away those electrons, right? So which means, what are we doing? We are decreasing the concentration of our hydroxide ions. Remember, hydroxide ions make for a base, so which means we are lowering the pH because we are taking away the hydroxide ions. So they say when the cell operates under standard solution, the pH will definitely decrease. And where does it decrease? For the anode, right? Because that is on the anode side. So let's see, the anode, the pH at the anode will decrease. So the correct answer is B. All right. And then they say to us, we've got two experiments that are conducted using a reversible reaction shown below. We've got hydrogen and iodine giving us 2HI. They say an equal number of moles of H2 and I2 were added to the container each time before it was sealed. Experiment A was conducted at 500 degrees and experiment B at 600 degrees, right? Now, let's first note, at 500 degrees, we seem to have a higher yield of the products than at 600 degrees. What does that tell us? Right? That an increase in temperature does not favor the formation of products. It does not favor the forward reaction, right? So in that case, it means that an increase in temperature favors the reverse reaction, okay? So means that reverse reaction is endothermic, meaning that the forward reaction is exothermic. Right, now they say to us, deduce whether the forward reaction is exothermic or endothermic and how the value of the equilibrium constant differs for the two experiments. Well, first of all, we've just established that an increase in temperature lowers the yield. So the yield is lower, meaning that Kc is less, okay? And so we've also established that an increase in temperature did not favor the forward reaction, so which means the forward reaction is not endothermic, it must therefore be exothermic. So the correct answer there should be B. Right, I hope that was clear, ladies and gents. And finally, well, not finally, I think we still have one more. So they say, which compound does not have a molecular formula C4H8O2? So remember, this is the molecular formula that belongs to esters as well as carboxylic acids, right? So methyl propanoate, so methyl has got 1, propane has got 4, so definitely it's an ester, it should have that molecular formula. So ethyl ethanoate, that's 2 and 2, that's sorry, I said that's an ester. The first one, A, was a carboxylic acid, right? It's a carboxylic acid that has a side chain on it. So in that case, it does satisfy that condition. So B is an ester with 2 on each side. Okay, so it does satisfy the condition. A butane 1,2 diol. Okay, and in fact that was supposed to be butyl 1,2 diol, but be that as it may, it is an alcohol, so it cannot have that formula, right? Even if it has 2 OHs, but it will not have that formula. You can try it out. And then finally, the propyl methanoate. Again, you've got 3 carbons and 1 that are separated by the oxygen. So in that case, it's 3 to 1, which is 4 carbons all in all. So it must satisfy that condition. And then finally, ladies and gents, they say, which alcohol cannot be dehydrated? Okay, now let's check. When I look at A, it is a tertiary alcohol, and note, because of it being a tertiary alcohol, it does not have an accompanying hydrogen next to it, so that we can apply Zaitsev's rule, right, to eliminate that hydrogen as well as the hydroxide. So in that case, that should be A, but let's see the others, right? If you look at this one, there's an H that accompanies that, so we can form that double bond. Okay, even for this one, there's an OH and an H next to it, so we can and we've got an OH as well as an H next to it. So we definitely can form, or rather we can dehydrate that. So the only one that does not have an accompanying H next to it is that A, which is a tertiary alcohol. And guys, that is how the cookie crumbles. We're going to be delving into question number 2 for our next video. Right, please do look out for it. For now, I'll see you guys next time. Shop, shop.